Hello, guys. Welcome to another episode of Cuda Education. So today we are adding three files and modifying two files, and we will get into detail in these files in another episode. But um, the changes for this specific episode is that we added three files, we modified two files, and then we also what we're rendering now is has been updated. So we're getting closer to doing our getting to our modern renderer application, which is the application freely available on the Apple Metal sample code library. And we opened a fresh Xcode project, Mac OS Xcode project, Metal Xcode project, what have you, and a blank project, nothing in it. And then we're slowly adding in stuff to get to our modern renderer application. So again, today we have three new files and we have two modified files. Now the output of all of these changes today is this right here. So now we have we still have our blue background, but now we have somewhat of a triangle. Now this is not your standard issue everyday triangle. It is this triangle, but I'm not going to go out there and start modifying stuff. I'm just going to follow the process as is. This is the triangle that the heavens have given us, and I'm just going to run with it, right? But let us just do a quick investigation into what was done with this change. In another episode, I will get into details about get into details for it for the specific changes. But right now, we're just keeping it light and airy and easy, and we'll get into the weeds a little bit later. So the first thing is that in the ViewController header file, we removed MTK view delegate conformance. Renderer handles it now. Okay. And then we also, in the metal file, the main file, main file, I guess I like to call it. It's simplified to a thin shell, creates the metal device, creates the renderer, sets the renderer as the MTK views delegate. All rendering logic moved to AAPLRenderer. So these two modified files basically tie into the fact that we have created three new files and we are now using those files to do stuff. So instead of it being stuff being declared inside of ViewController, whether it be the header or the main file, we are using these new files that we created to actually take on some of the heavy lifting. So AAPL simple.metal, this is two metal shader functions. Vertex simple shader takes a view projection matrix and position buffer, transform each vertex to clip space. All right, and then we have our fragment simple shader, takes a color and outputs it directly. We'll get into this in a little bit. We'll open up all the files and stuff, but let's just overview it for now. And then we have APL header and main file. The renderer class now owns the entire metal pipeline. So we have init with metal kit view, sets up the command queue, compiles shaders into a pipeline state, creates a depth stencil state, creates a vertex buffer with 3 triangle positions, creates a color buffer orange, and initializes the camera. And then we have our drawing MTK view. We have seen that before. Per frame updates the camera, encodes a single triangle draw with the view projection matrix, presents and commits. MTK view drawable size will change, updates the camera aspect ratio on resize. So that's basically when we change the size of the window, right? So right now I have it at full screen, but it could be not full screen. Okay, so let us go to APL simple.metal. Okay, abstract. Simple vertex and fragment shaders for basic geometry rendering. We include a bunch of stuff. Import shader types. We have simple vertex out, a strut, and then I guess this is a function, vertex simple shader, and then we do some stuff. Okay, again, this AAPL simple dot metal is transformed each vertex to clip space, right? So it does some stuff with that. And then fragment simple shader right here takes a color and outputs it directly. So right, these are two functions. So these are all the parameters for the vertex simple shader right here. And then we do some processing, and then these are the parameters for the these are all the parameters for the fragment simple shader, right? And we just return color. Okay, so that's the AAPL simple. Now AAPL renderer, header for the renderer class, which performs metal setup and per frame rendering. All right, so we have this here, and then let's go to the main file. Implementation of the renderer class, which performs metal setup and per frame rendering. All right, we've seen this stuff before, definitely device and command queue. We have now render pipeline state and depth stencil state, vertex buffer, color buffer, and then the camera. So AAPL renderer, the renderer class now owns the entire metal pipeline. So we have init with metal kit view and draw in MTK view, and also draw size will change. So we basically moved a lot of this stuff that was, I think, in ViewController before into the renderer file, which is to be expected. And so some of this stuff would look a little familiar. So remember, we assigned device and command queue just like we did previously. Now we're getting a little bit more into it. Load shaders and create the render pipeline state. Create triangle geometry, load assets. Where is this load assets? Create the camera. So AAPL camera, all of this stuff, and then return self. Now this is inside of the init with metal kit view. All right, and then we have load metal with view. Load shader functions from the default library. Create the render pipeline state. Create the depth stencil state. This is all inside of load metal with view. All right, load assets. Okay, so that's where our load assets was, right here. Self, create a triangle geometry. So this is this guy right here. Hard-coded triangle vertices placed in front of the default camera. Default camera position, this, looking towards that. Okay, so we have our camera and we have a hard-coded triangle. So this is what the people up above decided to use as their vertices. Don't ask me why, but I'll leave it at that. Okay. And then we have vertex buffer, triangle vertices, new buffer with bytes, triangle vertices, length, size of triangle vertices, and then options, MTL, resource storage mode shared. A single color for the triangle orange. So we have a color buffer, device, new buffer with bytes, color, length, size of color, options, MTL, resource storage mode shared. All right, so we kind of see the cadence of this thing now, right? So these buffer things, we have new buffer with bytes, length, and then options, right? So we kind of catch that vibe right there, and then we have our vertices for the load assets. MTK view, camera aspect ratio, drawable size will change. So this again, guys, is when we adjust the size of the window. The image should adjust accordingly. And then we have drawing MTK view. Per frame updates the camera, encodes a single triangle draw with the view projection matrix, presents and commits. Okay, so we have update camera matrices. This get the render pass descriptor. I think we saw this before, render pass descriptor, right? And then we should see some encoding and encoding, right? So create a command buffer and render encoder, right? So command buffer. So we've seen this before, guys. This is not nothing new. We're just putting it into a new class, into a new situation. So this stuff right here shouldn't scare us. So we have our command buffer, right? Because we did create the variables and all that stuff, initialize the variables and things. We have our encoder, and see now we're doing stuff between the encoding. We're not just start encoding and encoding. We're actually doing stuff inside of the inside of the brackets for the encoder. Set pipeline state and depth stencil state. Simple pipeline depth stencil state. So we set render pipeline state, set depth stencil state, set the vertex buffer positions. Okay. Set the camera view projection matrix. Set the fragment color. Draw the triangle. So draw primitives, MTL primitive type triangle, vertex start 0, vertex count 3, end encoding. So encoder. So this is end encoding. I'm going to say that we start encoding right here. That would be the most reasonable place. But in the previous episode, we had, we just had start encoding, end encoding. We didn't have anything in the middle. But now life gets more complicated, right? Because we have instructions that we'll dive into in another episode. Present and commit. So we have present drawable, current drawable, and then we commit the command buffer. So remember, the command buffer and command queue and all that stuff, it's a line of instructions that we submit to the GPU so the GPU can process stuff and then submit to the screen, right? So that's what the present drawable thing is, and then we actually have to, that's what this instruction is, and then we actually have to commit the command buffer so that these instructions are actually performed and done on the GPU, right? Nothing too crazy, guys. Nothing too crazy. We have seen this stuff before. We're just adding more complexity because we actually have to draw a triangle onto the screen, right? And that's it. Did we do? Did we do the main? Okay, so just real quick, let's just do the. So this was just the header file, and then this is now the main file. All right, notice that now we import AAPLRenderer.h. Okay, so we import renderer.h, and remember I said that the view controller, now instead of stuff being done inside of the view controller, it's being done in APL renderer. We still have our view did load function in the view controller main file, and configure the MTK view with a metal device. And yeah, notice that we create system default device. So we're looking for a metal 4 capable GPU. And if we can't find it, metal is not supported on this device, right? And then create the renderer, which takes over as the view's delegate. Yeah. But again, guys, like I said, we will dive into this code. So we're actually going to spend some time with this particular piece of logic, because we really have to understand, stuff's getting real now. Stuff's getting real. So we really have to understand what's going on here. I know it's just a simple triangle on a screen, but this is going to be our foundation for everything else going forward. Now, in the previous episodes, we just had a blue we had just had a window with a black with a blue background, right? But now we have a window with a blue background and then a triangle on the screen. So we have to spend time understanding exactly what's going on here. This is where things get real, and we need to understand it, because it doesn't make sense we add on more complexity and get into more stuff if we don't understand this right here. So we're going to spend some time on this, and we're going to be, I'm going to dive into each one of the files and, elaborate on what's going on with each piece of instruction, so that we get a proper foundation for us to then move forward and do some more interesting stuff. You guys, you have to pay attention to the numbering system. So this is probably going to be clean slate 1.6, and then for this particular thread, where I'm going to dive into the things specific to this episode, in more detail. So like if the numbering system is clean slate 1.6, then the detailed stuff related to 1.6, related to this discussion, related to all of this right here, I'm going to number it clean slate 1.61, 1.62, 1.63, 1.64, 1.65. So you guys know that everything related to 1.6 and details related to 1.6 is in those videos, right? Obviously, all of these videos will be added to the Apple Metal playlist, etc., etc., etc. But you guys, one of the important things in learning is that you have to be organized in the whole process. So, follow the numbering system. If you watch this video 1.6 and you're not really interested in getting into detail with these stuff for one reason or the other, no problem. Just skip to video clean slate 1.7, for example. Okay, you basically skip all of the things related to this discussion going forward, right? Wouldn't advise it, but you might have your reasons, or you might be already familiar with a lot of this stuff. Whatever your journey is your journey. But this is Cuda Education, guys. You know what to do. Like, subscribe, tell your friends. Let's build a community. Let's learn Apple Metal in 2026. Let's be in a good place towards the end of the year and the beginning of 2027. The bus keeps moving, man. It doesn't stop. Might slow down, but it don't stop. So just keep at it, guys. I'm certainly going to do that. We're going to dive into this stuff. I probably I probably work on the modified files first, so the view controller stuff, because we, see what the changes are with those, and then we'll dive heavy into the AAPL simple and AAPL renderer, just so I think that's a better approach, so that we could we could be in a good place and really understand what's going on. Thank you for watching. This is Cuda Education.